Today, let's talk Pythagoras. So this is something that you would have already covered in year 8, but we're going to look at it again today because it is something that you need to know for trigonometry. So this here is the Pythagorean theorem. So you might have seen it written one of two ways. You might have seen it as c squared is equal to a squared plus b squared, or you might have seen it written as a squared plus b squared equals c squared. Now they both mean the same thing. It really doesn't matter whether the c goes at the end or whether the c goes at the start. Personally, I like the c at the start, but whatever floats your boat. So here we have a triangle. Now Pythagoras is used to calculate missing sides of a right angle triangle. Now we can only use this when we have two given sides. So here in this particular right angle triangle, we have a side length that is 3 centimeters, and here we have a side length that is 4 centimeters. And we're trying to find the missing side up here. Now C is always your hypotenuse. C is your longest side of the triangle, which is pretty obvious if you think about it, because a squared and b squared are going to add to that. So you can't have one of the sides being longer than the hypotenuse. Hypotenuse has to be the longest side. So anyway, what we do to use Pythagoras to solve this particular problem is we need to fill in our blanks. So this here is our formula, and we just fill in the blanks that we have here. So this side is C, and it doesn't matter which of these two are A and B. So this one can be A, this one can be B. But it can go either way. So I don't know what C is, so that has to stay as C. A is 4, so instead of putting A, I write 4 squared. B is going to be 3, so 3 squared. So now, 4 squared means 4 times 4, which is 16. 3 squared means 3 times 3, which is 9. So 16 plus 9 gives us 25. But now I can't stop here. So I found what c squared is, which is fantastic. However, I need to find what c is on its own. So I need to somehow get rid of this little squared symbol, which is square rooting. So that's this symbol. So that's the opposite, so that cancels that out. So now we're left with c is equal to the square root of 25. If you type that into a calculator, you'll be able to find the answer, or it's a number that multiplies together to give that answer, so 5, because 5 times 5 is 25. Cool, and that's how we use Pythagoras to find the hypotenuse. Okay, let's do another Pythagoras question where we use the Pythagorean theorem to find the hypotenuse. So here in this particular question, again, I'm trying to find the longest side, which is automatically going to be your c, because your a squared and b squared add together to make c, so c has to be the longest side. Your hypotenuse also happens to be the one directly opposite this little square symbol down here. So this side length is 6 meters, and this side length over here is 8 meters, obviously not drawn to scale. So in order to calculate c, I'm going to take my formula and fill in the blanks. So I don't know what c is yet, so that has to stay as c. So this becomes c squared. A, now that can either be the 6 or the 8, it doesn't matter which one. So I might make this the A, and this can be the B. So instead of A, I'm going to be putting 8, because that's the length of my A side. My B side is 6, so 6 squared. So 8 squared is 8 times 8, which is 64. 6 squared is 6 times 6, which is 36. So 64 plus 36 gives me 100 equals c squared. But I can't stop there. I need to get c on its own. So I need to somehow figure out how to do the opposite of squaring something so that I can have it on its own. That's where this weird symbol comes in. Square root, both sides. Oh. So c, the square root of 100 is 10, because 10 times 10 gives you 100. Cool, so that is how we use the Pythagorean theorem to calculate the longest side, which is the hypotenuse.